for section 4.3. As of right now, we have two different ways to prove triangles congruent, SSS and SAS. Today we're going to get two more shortcuts. So the first one is ASA. For ASA congruence, you must know that two angles and a side included between them are congruent. So see how the side has to be between the two angles. So write a congruent statement for these triangles that are congruent by ASA. So we're looking for angle, side, angle, angle, side, angle. And then see how this is not included, so this is not going to work. So I'm going to start out with triangle SUV. So I started with 0, 1, 2 markings, so then 0, 1, 2 markings. So NEO is congruent to triangle NEO. Write a congruent statements for these by ASA again. So ASA, we're checking for that included side. ASA, the side would have to be over here, so this one is a no. ASA, the side is included. So 0, 1, 2, 0, 1, 2. So triangle OGH is congruent to triangle TCA. And again, please pause the video if the kids need more time to write. Here's our last theorem for today, AAS. So we have SSS, SAS, ASA, and AAS. You must know that two angles and a non-included side, then this is showing the congruence. So we have AAS, so we can actually skip a side in there. So AAS, order matters. So let's do a proof. Let's get our given information written down. Angle M is congruent to angle K. WM is parallel to RK. So number 1 is given. Number 2 is given. Let's check our marking. So angle M and angle K, and then we have parallel lines. So this brings us back to that chapter 3 where we have corresponding, alternate interior, alternate exterior, and all that. So our options for proving these triangles congruent, SSS, SAS, so then the opposite of that is ASA, and then the new one is AAS. So those are our 4 options that you need to keep in mind today. I should see those written on every paper you have. So to get these two triangles congruent, right away I notice this side. How are we going to get that side congruent? Reflexive. So let's get that out of the way. So WR is congruent to WR by reflexive, because we're probably going to need it. So as of right now, we have an angle and we have a side, and then we also need to look at order. So there's a reason they gave us parallel lines. So what I'm going to do is just extend this a little bit. So there's a line, and then here is our transversal. So now what happens in our picture, I see an angle here, and I see an angle here. What kind of angles are those? Angle MWR is congruent to angle WRK. So what did you guys say they were? Alternate interior angles. So because the lines are parallel, then the alternate interior angles have to be equal. So now if I redraw that top triangle, I have angle M, angle W, and then that side by reflexive. So then I can get the triangles congruent by AAS. So triangle WMR is congruent to triangle RKW. Just to mention, we will not have an angle, 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 and I can show you when we get back why we do not have one of those. And then we also do not have the other triangle that would be the opposite of this one, and I'll call that the donkey triangle. we don't have the donkey triangle. And if you don't get the joke, I'm sure somebody in the room does, but we do not have a donkey theorem that proves triangles congruent. Is it possible to prove that these triangles are congruent? So again, we're looking for vertical angles, reflexive, alternate interior, all that stuff. So A, I see an angle and a side, and then we get this other angle by vertical. So yes, these triangles are congruent because of AAS, and then in my explanation I would include vertical angles. Part B, I see NP bireflexive. I don't see any parallel lines, so I can't talk alternate interior, so this one is going to be a no. Because we don't have an SS. We have an SSS, but I can't get that third pair of sides. Part C, I see parallel lines, so then we got to be talking about our special angle. So if I do this, then here's my transversal. So what's true about angle 1 and angle 3? They are congruent because of alternate interior angles theorem. And then the same would happen if I highlighted this angle and the transversal. So then we get 4 and 2. So let me turn this messy picture out. So right now we have 1 and this angle matching to 1 and this angle. And then, yep, I bet you guys guessed it, this would be bireflexive. So AIA happened twice, so I'm going to write it down twice. So yes, these are going to be congruent by angle, side, angle. Make sure you go in order. The side is included in between the two angles. So why don't you pause the video, let them try this. So here are the answers. ASA, the missing included side would happen because of reflexive. Number 3, the missing angle would be because of vertical angle, so we say AAS. And then number 4, there's no connection with any other side or angle, so those would be a no. Here's the last one. So we need to get all this information written down as given. So RP bisect. So we are actually given no sides and no angles. So why do they have these red markings in here? So let's look. Angle SRQ. So angle SRQ would be this angle here. So then this RP bisects it. So then by the definition of bisect, we're going to get this angle and that angle the same. So let's write that down. So angle SRP is congruent to angle PRQ, and we knew that because of the definition of bisector. So same thing is going to happen with the other piece. So because this flips, we get that blue angle the same. So step 4, angle FPR is congruent to angle RPQ because of the definition of bisector. So right now, remember, we don't have that red piece the same, so we're just going to forget that's there. So we need one more piece. Our options are SSS, SAS, ASA, and AAS. Yep, I heard somebody say it, reflexive. So step 5 is going to be PR is congruent to itself. Bireflexive. So then we have our triangles congruent. SRP is congruent to triangle QRP because of angle, side, angle. So make sure if you don't understand the proofs, you reread them when you get home, watch the videos again, but you need to practice. You will have proofs on the Chapter 4 test. Save your questions for me when I get back.